Hi, welcome to AB Video 2.3F Part 2, Horizontal and Vertical Motion.
Tangent line. Okay, so looking at, that's all there is on there. This is just find the equation of the normal line, find the equation of each of the normal lines. Okay, so let's look at numbers 1 through 6, which now are the motion problems on this worksheet. Particle is moving along a horizontal line, so it is horizontal movement, which is why the position function can look very different. It can have trig in it, quotients, all kinds of things. It's not like acceleration due to gravity on planet Earth. S meters, so they are letting you know that your distances are meters and meters, is the directed distance from the origin at t seconds. So S is how far away the object is from the origin. It's a directed distance, so if S is 5, you're 5 to the right of the origin. If S is negative 5, you're 5 to the left of the origin. And they're letting you know that t is the time measured in seconds. They have a couple of questions. Determine when the particle reverses its direction, and determine the intervals of time when the particle is moving to the right and moving to the left. Okay, so when is it reverse direction, when is it moving right, when is it moving left? And you do have to be careful here. Don't assume that t has to be positive with horizontal motion. Let them tell you that if that's the case. Okay, so here's our position function. We know that it moves to the right when the velocity is positive. It moves to the left when the velocity is negative. So in order to decide when something is positive or negative, we're first going to find out when it's 0, because positive is greater than 0 and negative is less than 0. So I'm going to find the velocity. My velocity is my derivative of my position function, so it's 6t squared minus 6t minus 12. I will then ask myself, when is that 0? Now, you got to think about this. If an object, let's say, is traveling along this line right here, so it's traveling along, if it's going to change directions, it has got to slow down, and for a microsecond, it won't have any velocity at all, and then it'll start backing up and going back in the other direction. So the thing you need to understand is that the object will reverse direction when v is 0. It could possibly reverse direction when v is 0. It'll definitely be moving to the right when v is positive and moving to the left when v is negative. So I'm going to find my derivative, which is 6t squared minus 6t minus 12. I'm going to ask myself, when is that velocity 0? Do yourself a favor, factor out the common factor of 6. This factors very nicely. And I find out that the velocity is 0 when t equals 2 or t equals negative 1. Now, you cannot assume that just because the velocity is 0 that it is reversing direction, because it's possible that the little bug is traveling along the line, slows down, stops, and smells the roses for a little while, and then keeps on going in the same direction. So you don't know that it's definitely changing direction there unless you check. So here's what we're going to call a number line graph for this. Okay? So what we have is, I have a number line. I'm going to place my 2 times, t equals 2, t equals negative 1. So I have a dot at each place. The numerator, all these things represent the velocity at those times, and the denominator is going to represent where the particle is moving. So I know that my velocity is 0 at t equals negative 1 and at t equals 2. I then pick a number to the left of. Now remember, we talked about this. Since both of these factors have odd exponents, you know the signs will alternate. So really, I just need to plug in one number and go from there. The actual easiest number for me to plug in is the number between negative 1 and 2, which is 0. So if I plug 0 into this, I'll get 0 plus 1 is positive, 0 minus 2 is negative, so I have a positive times a negative times a positive. And therefore, I get a negative answer. Since the signs alternate, then it'll be plus minus plus. When the velocity is positive, the particle is moving to the right. When the velocity is negative, the particle is moving to the left. When the velocity is positive, the particle is moving to the right. So you have confirmed now that the velocity is 0 at both of these places, and the particle is actually changing direction. It was moving to the right, and now it's going to move to the left, and then it's going to move to the right. So the particle moves to the right for t, element of negative infinity to negative 1 and 2 to infinity. It moves to the left for t equals negative 1 to 2. And of course, it is actually reversing direction at v equals 0. I want to talk a little bit about this blue and why I crossed it out. If you were just solving an equation, you could absolutely just say, let me just divide both sides by 6, and I'll get 0 equals t minus 2 times t plus 1. However, because we're looking to see what sign this has, if this had been a negative 6, that would change all these signs to their opposites. So be careful. Don't divide through by a constant like that. That's not going to serve you well. Okay, so from the worksheet number 8, let's have a look at the worksheet number 8 in this second section. A rocket is fired vertically upward from the ground with an initial velocity of 560 feet per second. Writing the equation for the motion. How high will the rocket go, and how long will it take the rocket to reach that highest point? What's the instantaneous velocity of the rocket at 10 seconds and 25 seconds? And then they're going to ask for the speed at 10 seconds and 25 seconds and the speed when it hits the ground. So it's a multifaceted question. All right. So this is in feet. So we're going to have negative 16t squared plus v0t plus s0. It's from the ground. They told you the initial velocity. So therefore there's your position function. How high is the rocket going to go? And how long will it take to get to that highest point? So what you have to realize, just follow this cursor. If I toss something upwards with an initial velocity, it's going to go very fast and slow down as the gravity of the planet pulls on it. And right when it reaches its maximum height, the velocity will be 0, because it's negative 30, negative 10, negative 5, negative 1, negative a half, negative a quarter, and it reaches the maximum height, velocity 0, and then it starts coming back down. Negative a quarter, negative a half, negative 1, negative 5, etc. Okay? So, what you know is the maximum height, it reaches its highest point when the velocity is 0. So we have to find the velocity from the position function, which is negative 32t plus 560. We set that equal to 0, and we find out that it reaches its maximum height at 17.5 seconds. As far as what is the maximum height, we will now plug that t value into the position function, which is the height. And you'll get a height of 4,900 feet. They want the velocity at 10 seconds and at 25 seconds. Here's our velocity function. So we plug in 10 and we plug in 25. And of course, that'll be in feet per second. And part D, what's the speed? Well, we have, remember the speed is the velocity. So we just take the velocity, the speed at 10 seconds is the absolute value of the velocity at 10 seconds. So what happens is they're both positive. What is the speed when it reaches the ground? Now remember, we know that when it reaches the ground, the height is 0, not the velocity. So the height is 0, you set your height function equal to 0, you will solve and find out that it happens at 0 seconds, which is before you toss it, and at 35 seconds. So the speed at 35 seconds is the absolute value of the velocity at 35 seconds. So you would go back to your velocity equation on the previous page, plug in t equals 35, find that it's negative 560, and then take the absolute value of it. And of course, its speed will be measured in feet per second.